Hi, I'm Olivia Kolovich, a senior at the University of Florida studying economics and sustainability in the built environment. For my sustainability degree capstone project, I decided to do it on a topic that I'm learning about at my summer internship at Siemens Smart Infrastructure. I'm learning about how building performance services can reduce the energy consumption of buildings, as well as save building owners money in utility bills and extend the longevity of a building's life cycle. How can building performance services, sometimes referred to as energy service company projects, minimize a building's environmental footprint? Sustainable development was famously defined by the United Nations Brundtland Commission more than 3 decades ago as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Since then, economic growth and development has continued. Electricity production is the single largest source of global greenhouse gas emissions, and buildings consume half of all energy produced. Reducing the environmental footprint of the built environment is critical to safeguard environmental quality to ensure future generations are afforded the same quality of life. One way to do this is to improve building performance and efficiency, allowing less energy to do more work. Building performance services can be broken up into a few different categories: improving operation and maintenance practices, commissioning a building, simple energy tune-ups, and then capital-intensive equipment replacements. Energy service company, often referred to as an ESCO, is a company that specializes in building energy efficiency and performance.
Hi, my name is Jason Taylor. I'm one of the account executives here at Siemens. One of the things that we do specialize in is reduction in energy. The way we go about doing that is we generally will sit down and work with our customers to find out where they're at in that process. Do they know what their energy spend is? Or do they have plans to try to reduce their energy, and what are they? And from that education, we start to kind of narrow down what it is that they need and what our next steps are. Some of the types of energy efficiencies that we really kind of hone in on would be lighting retrofits. From the HVAC side, generally we're looking at how they control their buildings, if there are opportunities for savings. Demand flow is something that Siemens has. It's proprietary, that really helps with large chiller plants and large industrial facilities. The way it does that is by optimizing how the plant operates from the standpoint of the water temperature and the flow that is required in the building.
Hi, my name's Don Pittman with Siemens. One of the things that I do to help my customers reduce their EEUI is to work with them in different ways. Siemens has a lot of different types of things we do. We can be an advisor and a helper in different places at different times. One way is through helping them develop programs that improve the building's performance through repairs and through capital improvements. And another way is to help them operate the buildings better through our control systems and things like that.
I'm here at the FSU Kasha Laboratory at the Institute of Molecular Biophysics. This building was constructed in 1963 and renovated in 2002. It's 5 stories and it's mixed use with both offices and laboratories, so there is special ventilation requirements. Siemens has been tasked to commission this building, see how it's currently operating, and identify ways to improve the building performance and energy efficiency. The building systems that were evaluated include the air handling units, exhaust fans, and variable speed chilled water and hot water pumps. The metrics observed were the air handling units supply and return air temperatures, pumping performance, water flows, and flow meter accuracy. In addition to identifying operating issues, Siemens recommended 4 energy conservation measures: installing occupancy sensors, adjusting the demand control ventilation, building schedule and set points, and adding energy monitoring equipment and software. The upfront investment in this project was $265,000. The savings will result from an annual utility bill reduction of $38,000, and the project will pay for itself in 7 years. Throughout this project and my internship at Siemens, I've learned a lot about building performance services and reducing energy consumption on a large scale. I would like to thank my mentors here at Siemens, at the University of Florida, and those at UF-IFAS and FSU for being willing to chat with me about their experiences with building performance services.
and sharing their knowledge about the industry with me.